Okay, good morning, everybody. Hope you guys are doing well today. So we're going to continue to discuss what we were talking about yesterday, which is Chapter 2, Section 5, and absolute values. So this time, though, we are going to discuss how to solve absolute value equations. And it's a little trickier than it may initially seem because there's one additional step to solving these that wasn't something you had to do when you were just solving regular equations. So let's get started here. So what you can see is it says solve the absolute value equation, and it shows the absolute value of x is equal to 4. And what you have to realize here is there's actually two solutions to this absolute value equation. Remember, absolute value is asking you the distance from 0. And so this says what numbers are 4 away from 0. And as you can see down here, of course, the obvious answer would be positive 4, right? Because you start at 0 and you moved right to the 4, and that's been 4. But you also have to realize that this number over here, negative 4, is a distance of 4 from 0. And so both of these fulfill the requirement of what we have up here, which is to find a number that is 4 units away from 0. And so there's actually two answers to this. The two answers are 4 and negative 4. So we need a way when we solve these equations to be able to find both of the numbers that will fulfill the absolute value equation. So I'm going to show you how that works now. So the first thing that you do when you have an absolute value equation is you just rewrite the equation without the absolute values. It's very simple. Okay, so this is going to split into two problems, and this is how you end up with your two answers. And the first problem is just drop the absolute value and then solve it. So you're going to subtract 2 from both sides. And when you do that, you get y equals 2. And that's one of the two solutions. So if you plug 2 into that equation right here, you'd have 2 plus 2, which is 4, and indeed 4 equals 4. But the other equation that you get from this is you have to drop the absolute value equations again, but then you make the number that's outside on the other side of the equal sign negative. And so what you have is y plus 2 equals negative 4. And so when I subtract 2 from both sides, you end up with the answer y equals negative 6. And that answer also would make this equation true. If I put in negative 6 right there, negative 6 plus 2 is negative 4, but then when you take the absolute value of it, it becomes positive 4. So there are two solutions to these absolute value equations. You have to make sure you solve for both of them. So let's move on to B. We'll try this again. Same deal. This is going to split into two problems. The first problem is going to be f minus 5 equals 3. And the second problem is f minus 5 equals negative 3. And now I'm going to solve those two equations separately. But to solve them, you do the same thing. You're going to add 5 to both sides of this first equation, and you'll get f equals 8. Over here, you're going to add 5 to both, and you get f equals 2. So there you go. We have two solutions. So again, remember, these absolute value equations should come up with two solutions. All right, moving on to more absolute value equations, but these are more than one step. The last ones were one steppers. These are going to be two steppers. We do need to split these again, just like the last ones. So we're going to write 2x minus 1 equals 7. And then we're going to write 2x minus 1 equals negative 7. And from there, we're going to solve. We will add 1 to both sides of the equation. We'll get 2x equals 8. And then we need to divide both sides by 2. X equals 4. The next equation is plus 1, plus 1. So we're going to cancel out the plus 1 minus 1, same as the last one. We do get a different result on the right-hand side, though. You can see that negative 7 plus 1 turns into negative 6. And then we're going to divide by 2 on both sides, and you get x equals negative 3. So there are the two x values that would, if you plug those into the original equation, the absolute value of 2x minus 1 equals 7, would give you the correct solution of 7. All right, a few more here. Same deal. For part D, we're going to split this. It splits, remember, 3n minus 3 equals 12. So we just drop the absolute values and just write the equation. The second equation that you're going to get, we also drop the absolute values, but we make the number on the other side of the equal sign negative. Okay? And then these are just two equations that we proceed to solve. We're going to add 3. We get 3n equals 15. When we divide both sides by 3, we get n equals 5. There's that. So there's the first of two. Same thing over here. We're going to add 3 to both sides. 3n equals negative 9. And then we're going to divide both sides by 3. N equals negative 3. And there's our other solution. So these two were two-step equations because you had to do two things to both sides in order to solve for the variable n. Part C was the same way. The last ones are just very similar to the ones we just got done doing. We'll write the equation, drop the absolute values for the first equation, and just rewrite it. The second equation, you're going to drop the absolute value, but you're going to make the 7 negative. And that's how you do it. Every single one of these is going to be done this way. So add 1. We get 2p equals 8. Divide by 2. We get p equals 4. There's the first one. Second one, same idea. We're going to add 1 to both sides. That cancels. 2p equals negative 6. Then you're going to divide both sides by 2. P equals negative 3. Okay, so the last one that we're going to do is part F. Now, this one is tricky, and here's why. I want you to go back, and we're going to go back and look at the first 5 that we did. If you look at this equation right here, the absolute value of the stuff equals a positive 4. Over here, the absolute value of f minus 5 is a positive 3. If you look in part C, the absolute value of 2x minus 1 is 7, positive 7. Part D, the absolute value of 3n minus 3 is equal to 12. Part E, the absolute value of 2p minus 1, that equals 7. But this one's different. This one has the absolute value of 6y plus 5 equals negative 4. So I want you to think about that for a second. Is it possible for us to take the absolute value of something, and after we take the absolute value of it, it equals a negative number? And the answer is no, you can't. Once you take an absolute value of a number, that number should be positive. If it turns out to be negative, like it is in this problem, it means you actually made an error. So this one tried to trick us, but there is no, whoops, my lights went out. Try this again. We could wave at the motion sensor. There we go. There is no solution to this problem. And there's no solution because you can't have an absolute value equal a negative number. Now, that doesn't mean the solution can't be a negative number. And you got to be careful because there is a difference. As we had in part E, you can see P was negative 3. What it means is the absolute value equation cannot equal a negative number. All right, guys, that's what I got for you today. Hopefully that made sense. Have a great day.